System by substitution. Remember step 1, step 2, step 3. Substitution, we want to be able to isolate for one of the variables and substitute into the other equation. You want to be able to be smart about what you choose for the first equation. You want to be able to leave the variable that's already by itself. Makes it a little bit easier, you end up with less fractions. So in this case, I'm going to go and use the first equation. So for step 1, I have x plus 2y is equal to -9. You want to be able to leave that x by itself. Therefore, I'm going to move the 2y to the other side. It's going to become a negative. X is equal to -2y minus 9. Now that I know the value of x, which is -2y minus 9, I'm going to plug it into the other equation. Step 2. I have 6x plus 2y is equal to -4. But instead of the x, I'm going to replace it with the value of x, which is -2y minus 9. So 6x 2y is equal to -4. But instead of the x, I'm going to replace it with -2y minus 9. I'm going to use my distributive property to simplify. So it gives me -12y minus 54 plus 2y is equal to -4. I'm going to combine my like terms, and then I can solve for y. So -12y plus 2 gives me -10y minus 54 is equal to -4. And now that I combine like terms, I can move my 54 to the right, becomes positive 54. -10y is equal to 50, positive 50. I'm going to divide by 10 on both sides, or by -10, so y is equal to -5. I found my y value, so now I need to find my x value. I'm going to find my x value by plugging it into this equation. You can plug into either one of those two as well, but I prefer to use this one here. So I'll be step 3. X is equal to -2, but instead of the y will be a 5, -5. So it gives me x is equal to 10 minus 9, therefore x is equal to positive 1. My solution is a point, positive 1 and -5. Remember, we're trying to find out where the lines cross, so I need to see your answer as a point. Example number 6. Solve the following system of equations. It's a system because we have more than one equation. If you notice, in this case we have an x, a y, and a z. We have 3 unknowns. Therefore, we need 3 equations which are given to us. We want to decide if we want to cancel the x's, the y's, or the z's. You'll get the same answer, but usually one of them is easier, and in this case I believe the y looks much easier to cancel. So I'm going to cancel the y's. I'm going to cancel the y's twice by using 2 different equations each time. So let's see, I'm going to grab the second one and the last one, and I'm going to multiply by -1, the second one. And therefore, that y's will cancel out. Let's see, that gives me -5x minus 3y minus 6z is equal to -7. I double check that I multiply correctly. Negative, negative. The bottom one stays exactly the same. So we have the y's cancel. We have 1x, or just x, is equal to, minus 4z, excuse me, is equal to 2. That gives me positive 1x, that gives me -4z, the y's cancel, is equal to 2. I want to be able to grab 2 other equations and cancel the y's again. So I'm going to grab the first one and the last one, and I'm going to multiply the first one by -3 to cancel the y's. That gives me -6x minus 3y minus 12z is equal to -9. The second one stays the same. Now if you use two other equations different from the ones I used, if you use number 1 and number 3, at the very end you should end up with the same answer. So the y's cancel again. Remember, you want to be able to cancel the same variable twice. That gives me negative 1x minus 6z is equal to negative 2. I'm not going to combine those two equations, and I want to cancel the x's or z's. In this case, it's actually pretty nice because the x's automatically cancel. Sometimes you might get large numbers. You might have to cancel the z's, and you just have to make them 12. Multiply this one by negative 3 and this one by 2. But in this case, it cancels pretty nicely. Negative x minus 4z is equal to 2. Negative 1x minus 6z is equal to negative 2. The x's cancel. So I have negative 10z is equal to 0. Having a 0 here, it's okay. Some of you guys stop at this point and say, oh, it's no solution, which is false. We need to divide by negative 10. Any number, 0 divided by any number will give us 0. I found my first value. Now I'm going to plug into the first one or the second one from here. So you can plug it here or here to find the value of x. I'm going to plug into the first one because it has smaller numbers. So let's go and find x. That gives me x minus 4, but instead of the z, I'm going to plug in a 0. Negative 4 times 0 is 0. So I just have x is equal to 2. Now that I have two values, I can go and plug in both values into any of those three equations to find the value of y. They all look pretty similar, so I'm just going to plug it into the first equation. I'm going to find y. That gives me 2x plus y plus 4z is equal to 3. But instead of the x, I'm going to plug in a 2, and instead of the z, I'm going to plug in a 0. That gives me 4 plus y, that cancels out, is equal to 3. Move my 4 to the right, becomes a negative 4. So it gives me y is equal to negative 1. So my solution is a point on a three-dimensional scale. The x value is 2, the y value is negative 1, and the z is 0. Perfect. Remember, if you make a little mistake, you just have to go back and find it. You have to multiply negative 3 times 2, they do it correctly. Negative times a positive is a negative. Negative times a positive is a negative. 3 times 4 is 12. 3 times 3 is 9. Negative times a positive is a negative. You have to go through the whole process and check step by step. Many of you guys just make one little mistake. Let's continue on the back side. Which of the following sentences is true about the graphs? Which one's true? So we have to analyze each of the answers and determine. Now you can do two things. You can go and graph them on a separate piece of paper and then compare all of your answers. Or we can just go through each of the options and analyze both equations without graphing it. We're going to do it without graphing it. First, it says the vertices are maximum. So both vertices are maximum. So you have to think, okay, how do I know if a graph has a vertex that's a maximum or a minimum? Correct. The a value, the slope in this case. The slope is positive, so that means that the absolute value is facing up. Therefore, the vertex is the lowest point, which is the minimum, correct? This is the lowest point on the graph. On the second graph, it's also positive, so it's also facing up. The vertex, it's also the lowest point, therefore it's the minimum. So the vertices are maximum? No. The graphs have different shapes. What determines the shape of a graph? Do you remember? The shape of the graph is determined, correct, by the slope. So one of them is going to be wider than the other one. So they do have different shapes. One of them has a slope of 5, the other one has a slope of 3. And they have different vertices. Well, let's check. The vertex for the first one is positive 3 and negative 3. Vertex for the second one, remember, the h is always the opposite. So yes, they do have different vertices. Let's continue with the choices just to make sure that we got it correct. Do they have the same shape? No, we determine that they have different shapes because of the slope, so that's wrong. One graph has a vertex that's a maximum, and the other one has a vertex that's a minimum. No, in this case we decided that they both are minimum. Let's continue with problem number 8. What system of inequalities represent the graphs below? So we have a horizontal line. Remember, X, Y, Vanessa Hudgens, or Van Helsing. X value will give you a vertical line. Y values will give you a horizontal. In this case, it's a horizontal line, so it should be a Y, and they both, all of them are fine. And also for your line, they all have the same equation. So we're just going to be concerned about the shading. They even have, all of them are dash. And they're all dash. So we're just going to be concerned about whether it's greater than or less than. Let's work on the first one. If you look at the first one, did they shade the top or did they shade the bottom? Did they shade the top or did they shade the bottom? Correct. In this case, they shaded the bottom section. So that means that this is going to be less than. So it's not. So I know it's not A and it's not B because they both are greater than. So it has to be either C or D. For the second equation, we need to decide, do they shade the top or do they shade the bottom? And if you're not sure, just please go into one of the points. Where did they shade? They shaded the bottom. So that one should also be less than. And you need to show me the work. Some type of work that I know that you actually understand it. So they shaded the bottom as well. So it's not letter C because that's greater than. So in this case, it's letter D. If you have questions, just email me and I can respond. I'll be here in the morning in case you have any additional questions.